Hello, thank you for joining my 10 minutes experiment. My name is Yuji Otsuka from Similar Exam. Today, our topic is this one, eggs. So here is the water in the container. Then if I this egg into the water, what happened? Maybe you can guess it's sinking to the bottom or floating in the water, under the water, or floating near the surface, water surface. So let me try it. I measure this egg's weight in advance. Its value to 65.5. 65.5. I measure this one by this one. Okay, so please memorize 65.5 grams. Then I try. Okay, so this is answer. So egg is now just at the bottom, okay, not floating. But if I put some, this is a salt, okay, put some salt, then what is happening? So I also measure this weight, salt weight in advance. Its value, it's 10, just a 10 grams, 10.0 grams. Okay, so I put this 10 grams salt into the water. It will be salt water. So before putting the salt into the water, I once for a short time I remove these eggs and then put into the salt. Okay, then stir. Okay, it's already salt water. Then I try this, put this egg into the salt water. Okay, please observe. So this time, egg is floating near the surface. Just a top part over the surface, appear over the surface. Okay, and then it's floating near the surface. Okay, so you had an experience swimming in the pool or river, or please compare when you are swimming in the sea. It's a salt water. Maybe you feel your body is lighter than in the river or in the pools, in the water. Okay, so this egg is now floating in the salt water. Okay, but here is another water. Yeah, I try to put this pure water into the salt water. Then please observe the eggs. Okay, so now so I fill the water to the maximum. It's now 250 cc, 250 cubic centimeters. Okay, then I pour. Sorry, I pour some water little by little. Then please observe. Can you see? It's still floating. Egg is still floating near the surface. I add more. Just a simple little, but coming back to the surface again. So I put some more. It's still near the surface. I put some more, a little more. A little more. It's still coming up a little more. Very little more. Okay. It's a good position. So now this egg is just floating under the water, in the water. So in this situation, what is happening? Sorry, now the water level is around 55. 55. So it means initially water level is 250. Then now 55. So I put some water into the container, 195 cc. 195 cc. Put this amount of water into the container. Then now it's floating. Okay. So what is happening? So look at this picture. So egg is now floating in the water, under the water. Then egg has a weight. So it's a gravity of force, also gravity, this one. And then in the water, in the salt water, we have another second force. It's a buoyancy. It's a lifting force, supporting force. Okay. These are opposite way. These are opposite direction. Then they are making balance. That's why this egg is floating in the water, under the water. Okay, so it's now this buoyancy, lifting force, and the weight of egg is a equal value, like this. So I want to ask you, what is a buoyancy? This is a Archimedes. Do you know Archimedes? It's a Greek, what should I say, old scientist, ancient scientist. And the Archimedes principle. The buoyancy is he said, buoyancy, he found this principle. Buoyancy, the weight of fluid, liquid, displaced by body of eggs. Okay, once more. Buoyancy is the weight of fluid displaced by the body of eggs. So these eggs remove the seawater because it's existing around here. So it's remove the salt water. The weight is a buoyancy. So suppose if you fill the salt water in the eggs, the weight is a buoyancy. Okay, the value is the same as a buoyancy. So we can express buoyancy like this. Rho, it shows the density of fluid, and V, it's a volume of egg. So density multiplied volume. It's a, if you fill the salt water in the eggs, it's buoyancy. So we can express density multiplied volume. Then in this case, they are making balance. So equal eggs weight. Okay. So, sorry. So now we can get this formula. So we can calculate this density. According to the definition of the density, it's a weight divide its volume. In this case, total weight, it's contained weight of solid and water, initial water weight, and additional water weight. This is the total weight. Then divide salt volume, initial water volume, and additional water volume. But this salt water, salt volume, salt dissolved water, so the volume has nothing, zero, it's almost zero. So you can ignore this value. So this water volume, it's the same value as this volume, value of water. In the case of water, it's the same value. Volume and weight is the same value in this case of the water. Okay, and additional water volume equal the value of weight. Additional water weight. Okay? So we can get this formula. So we can calculate this X volume equal mass egg divide density. Then put this formula into the law. Okay. So now it's ready for calculate X value. X volume. X weight is I measure it in advance, 65.0, and salt weight is just 10.0, and water initial water weight is just 300 grams, and the additional water weight it's 195 grams. So we can calculate, put this value into the formula, and finally we can get 64.2 cubic centimeters. Okay, so please remember this volume. Okay, 64.2 cubic centimeters. Okay, 64.2. Okay, let's go back to the camera. Okay, so now I measure the X volume directly. So it must just now water level is around here. Here. Okay. Then I remove the eggs. I remove eggs. So water level is here. Okay. So if here is the water between this position and this position, it's the same volume of eggs. Okay. So I measure this volume directly. This is empty now. Then put more water to the initial position. Okay. It's now initial water level. Then I measure to the next position. Then water, it's a mist cylinder. A bit more. A bit more. Oh, too much. Sorry. No? Mm. Okay. So now its value is sorry, I need glasses. It's now volume is around sorry, just a bit more. Sorry, once more. Sorry, we have to water in the we have to put this some more water into that. Okay, so I measure the volume. The 60 around the 65 around the 6. Can you see? Maybe you cannot see the scale. So 65 around the 65 cc. So from the according to our calculation, it's a 60.5. I forgot the value. So just go. Sorry, just go back. 60 point, sorry, 64.2. So now we are measured directly around the 65 cc. So it's almost the same. Okay. So we can get the volume by calculation. Okay. A little difficult process, but you can understand that buoyancy equal eggs of buoyancy equal eggs mass, and buoyancy equal to the weight of liquid replaced by the eggs. Okay, this is a Archimedes principle. Okay, it's a long process. Oh, okay, okay. So that's all for today. Thank you so much. See you. Bye bye next time.